So, in this video, I will be discussing SystemVerilog system tasks, and those system tasks are $display, $monitor, $strobe, and $write. I will try to explain each of them in details with the help of examples, but firstly, let's hop on to our Verilog timing region diagram to understand it better. So the system tasks such as $display and the $write executes or operates in the active region, whereas the system tasks such as $monitor and $strobe they operate in the postpone region. So this does affect a lot, and we will understand it with the help of few examples. So let's go back to QuestaSim. So for our first example, I will write a very simple SystemVerilog module. I will declare two logic variables. First one is A, the second one is B. So firstly, let's assign some value to A. I will assign 1. Then I will use $display. So the $display prints the value immediately whenever it is encountered, and it operates in the active region. So let's use $display to print the value of A. Let's run the code. So as you can see here, we have printed the value on the console. So yeah, it is that simple. And now let's go through $write. So $write is very similar to $display. The only difference is that it doesn't come with a new line appended during the end of the sentence. So just give a new value to B. Let's give it 0, and here I will write $write. And I will print the value of B using $write. Let's run the code again. So as you can see in the console that both the values of B and A are being printed on the same line. It is because by default the dollar display comes with a new line, but $right doesn't have that. That is the only difference between $right and dollar displays. So suppose if I add a new line right here, it literally becomes dollar display. So let's run the code again. See, now the value of A has been printed on the second line. So what happens if we do some little modification with the blocking assignment and we make it a non-blocking assignment? Similarly, I will do that for B. Now let's observe that what will happen. Now, as you can observe here, both A and B are printing undefined value, which is the default value for any logic variable which is not initialized. So why is this happening? Like, I mean, previously it was working with the blocking assignment, but why not with the non-blocking one? It is because of the timing region. So in my previous video, I have already described the operation of a non-blocking assignment and a blocking assignment. A non-blocking assignment operates in NBA region and a blocking assignment operates in active region. So by the time the value is assigned to this, the $right and $display are already executed in the active region. So for that particular reason, $right and $display is not printing the value for this case. So we can make it work just by adding a delay and it will print the correct value. So you can see right here that it does work. But what if we want to use the system tasks in the same time slot? We can do that using $strobe and $monitor. So let's replace $right and $monitor with these two. So as I have already discussed that $stop and $monitor operates in postpone region, and the postpone region comes after the NB region where the assignment of LHS is done. So what are the differences between these two? So the $strobe is very similar to $display. The only difference is that it works or operates in the postpone region and it prints the value immediately. But for $monitor, it continuously monitors the value inside its sensitivity list. And here I think I made a mistake, but somehow it still worked. I don't know how. So if any change is noticed inside its sensitivity list, it will print the value. So let me demonstrate that how both of these differs with each other. So to do that, I will assign the value in the next time slot. And now let's see how does this change our output. So as you can observe right here that the $monitor is working perfectly. So what happens here that $monitor is not limited to any time slot. It will continuously monitor any changes inside its sensitivity list throughout the entire code. So what happens here that $strobe $strobe is printing the default value or the value which was in the given time slot, and it was X, which is undefined. And $monitor, it prints both the undefined value, but after the next time slot, when it notices the change in its value, it also prints that value. So to understand it better, let me add one more thing. Okay, let's run the code once more. Okay, right here you can observe that the dollar $strobe is only printing the value at time 0, and it is only limited to that particular time slot. And as for dollar $monitor, it prints the value for both the time slot 0 and the time slot 1. Even though it is not declared inside the time slot 1, it still detects the change in the next time slot, and hence it gets activated and prints the value inside its sensitivity list. Also, there can be only $1 monitor activated in a given time slot. So, like if we have $2 monitor in a single time slot, the later one replaces the former one. And to demonstrate that, I will replace this with dollar $monitor, and I will run the code. So, as you can observe in the console, that this dollar monitor is not printing the value of B. It is because they both of them are in the same time slot, and this dollar monitor which prints the value of A is replacing this one. So for that particular reason, we are only noticing the value of A. So what happens if I use this dollar monitor in the next time slot? Let's find out. Okay, let's run the code. So as you can see right here that the first dollar monitor did work for the time slot 0, but since there is another dollar monitor in the time slot 1, this dollar monitor replaces this one. So this detailed comparison arises few questions. So first of all, so why will we ever use dollar display over dollar $strobe? I mean, like for non-blocking assignments, dollar display will not work if you use that in the same time slot, and dollar $strobe will work since it executes in the postpone region. So why not we always use dollar $strobe? So to demonstrate that, I will help you with an example. So I will declare an unpacked array of 10 ints and using for each, I will assign some values to each element. and during each iteration, I will display the assigned value. Let's run the code. Okay, there is a compilation error. Let's see what I did. Okay, forgot to mention the initial block. Oh my god. Now it should work. So as you can see on the console that each iteration of display is printing the value correctly, and these are the elements which I assigned to the variable A or to the array A. So what happens if I replace this $display with $strobe? Let's find out. So I will run the code once again. So as you can see on the console that the $strobe is only printing one time and it is printing 0. So this ambiguous behavior is undesired and it's evident because of the fact that $strobe operates in postponed region. So for this particular cases in which we are iterating through the loop for some array elements, and to print those values we will be needing $display, and for such cases $strobe will not work. So allow me to go through an example in which we will understand the differences between $display, the $monitor, and the $strobe in a better way. I will declare two packed arrays. I will declare a $monitor at the beginning. So this $monitor will continuously monitor the values of A and B with respect to its time slot. Now let's write a for loop. It will iterate for 4 times. Inside this for loop, I will be using a $strobe. Just copy this and change it to $display. I will use a case statement here. So for this case, I will do nothing. And to make it happen, I will just write begin and end. So basically, this does nothing. I will just copy and paste it. And this will be display number 2. Great. Yeah. And at the end, I will add a delay. Let's add it by 1. I will go ahead and compile the code and check for errors. Yeah, there are no errors. Let's run the code and simulate it. So here we can observe the very first thing we are seeing is the dollar display, the display number 1 at time slot 0, which is this display. And this display is printing the value at that time slot, and the value at that time slot was undefined. So that's why it printed undefined. Then after that, on the same time slot, we go through that display number 2, and by that time the A is assigned with value of 4. So it is because we are in the first iteration of the loop. And as per the case statement, if the I is 0, we will use the case number 0, which is A equals to 4. So what happens after that? That the monitor notices the change in its sensitivity list, and since it operates in postpone region, it executes after the display statements. So since A turns 4, monitor displays the value, and right after that, strobe displays the value in the postpone region. So after that, in the time slot number 1, you can see right here that display 1 is printing the value of A equals to 4, and B is still undefined by that time. So right here we reach the case number 1, and the case number 1 is B equals to 1. So because of that, the next display, which is the display number 2, will print the value of B equals to 1. And right after that, in the postpone region, this monitor observes the change inside its sensitivity list, and it prints the value of B equals to 1. Similarly, the strobe prints the value of B equals to 1. And after that, in the time slot number 2, we see the display printing the previous time slot value, and that is the display number 1. And we reach the case number 2, and case number 2 literally does nothing. Still, this display will print the value because unlike monitor, it prints the value immediately. So after that, the dollar $strobe prints the value in the postpone region, and it also prints the value immediately like dollar $display. And then we move on to the next time slot. Here you can observe that the dollar monitor doesn't get anything changed inside its sensitivity list, so it doesn't execute for this particular time slot. So moving on with our next time slot, we have our display number 1, which will print the current value of A and B, as you can see right here. Then after that, the value of A and B is updated with 9, and here we can see that B is getting the LSB bits and A is getting the MSB bits, which are 0, right here. And after that display number 2, our monitor will notice the change inside its sensitivity list, and it will also go ahead and print the value in the time slot number 3. And right after that, the $stop will also print the value in the postponed region. So now what about $right? So $right does have few usages, and I will demonstrate it with an example. Now for this particular example, I will be declaring a 2-dimension unpacked array. The first dimension will have 4 elements and the second dimension will have 6 elements. I will iterate through each dimensions and assign some value using for each. Let's okay. Should write it inside initial begin. The value should be the first dimension multiplied by 10, then added by the second dimension. Okay, so after that, I will be printing the value in such a way that each elements of the first dimension will be printed separately in 4 rows, and each rows will have those 6 elements. And using right, it is very convenient. Let's do it. I will iterate through the first dimension. Then after that, I will display the iteration variable. Let's give it 3D. Then I will iterate through the second dimension. We can do that just by doing this. And then here, we will continuously iterate through the second dimension and print the value. Let's use percentage 5D. And we will append a new line right here. Now you will understand that why I did all this thing. So first I will check for the compilation error. Okay, it is error free. So I will go ahead and run the code. Okay, so I did mess up. I knew it will happen. So instead of using a new line here, what we can do is we can use a blank display right here. So this display does nothing. It will just append a new line. So let's run the code again. All right. So you can see how beautiful it is. So for such scenarios in which you want to print the two dimensions or multiple dimension elements of arrays in an organized way like this, the write becomes very useful. So at the end, each of the system tasks that are monitor, strobe, display, and write are useful in their own way. So I hope you find this video useful. Please stay tuned for more, and thank you so much.